How was your weekend?
You already know, Brian. It was
Yeah,
busy.
I was making conversation though.
I see. It was busy. How was yours?
Uh,
You said your
and
Saturday wasn't too cool, but I hope it got better in the evening when you showed up at the pig roast.
yeah, very much so.
So we're gonna roll a fair-sided die, guys. Okay. Um, A is the event that we roll a 1, 3, or 5. B is the event that we roll a 1, 2, or a 3. Okay. Let's make a 1, 2, and 4. C is the event that we roll a 1, 2, 3. I'm sorry, 1, 2, or 5. Is that going to work? Oh, that's going to be nasty. Let's make B. I have to, when I draw the Venn diagram, I have to make it drawable. So let's make B be a 3, 4, or 5. That'll work. And C is the event that we roll a 1, 2, or 3, or 4. Okay. So find the probability of A, probability of B, probability of C. And then we find, did I show you the format for a conditional probability? I can't remember. Did I show
I
you
don't
what
think
this
so.
means?
No,
Okay.
we did not talk about that.
All right. Probability, this notation, you guys ready?
Yes.
This notation means, well, here, let me draw it out first, and then we'll talk about the individual components. But we say that this is the probability of A occurring. Are there two R's in occurring? I think there are.
Uh, yes, I think so.
Given that, okay, B has occurred. Oh, man. Okay. So this is what the probability, this is what this notation means. And the definition of conditional probability is as follows. You take the intersection of the two events, you take its probability. So it's equal to both events occurring divided by the probability of the given condition. Okay? All right? Now, do we need a review of the discussion of conditional probability, or are you guys ready to dive into this problem? Talk to me. I remember we briefly discussed it for a few minutes on Thursday, the whole idea of conditional probability. And I gave you
One
a
thing
few
that
examples.
kind of
Oh,
caught me was you said if like A increases the chances of B, then it
sure.
also works the reverse way.
Absolutely. Yeah.
Is it always in the same amount?
No,
Based off this equation, it
nope,
looks like it's
nope.
not.
It's
Okay.
not. It's not, Brian. Um, we talked about like weather, right?
Yeah, we're
Um,
using weather.
yeah. If A is the probability that it snows tomorrow, B is I'm sorry. A is the event that it snows tomorrow. B is the event that the month is tomorrow is some day in the month of January. Well, the probability of A definitely affects the probability of B and vice versa, right? Um, A is the event that you're taking. Here's one. A is the event that you're taking physics this semester or some given semester. B is the event that you get a 4.0 GPA for that semester. A definitely does affect B, doesn't it?
Yeah,
Yes, no?
does for me.
Yeah, it does for most students. I mean, it doesn't preclude, but it affects the probability of getting a 4.0, or if you've gotten a 4.0, it affects the probability that you had physics that semester, because physics is usually, I've said before many times, physics is something you survive. If you get a decent grade out of it, that's a bonus. So in our notation, gentlemen, B is the given event, right?
Yes.
A is the conditional event. Does everybody see that? Does anyone not see that? Also, can I get rid of important dates? Talk
Yeah,
to
we
me.
have a screenshot.
Okay, thank you. All right, thank you very much, guys. I haven't looked at who's online. Do we have a full quorum today, or are we missing a couple?
I'm not sure what.
We should
We
have
have
7
7.
besides me. Looks
Yeah,
like
we're
we
good.
got everybody. Cool. Great. Okay, so I'm going to bring our find stuff over to where I had important dates so we can actually work. My eraser doesn't want to stay. So we want to find probability of A, probability of B, probability of C, probability of A given B, probability of B given A, probability of A given C, probability of C given A. We could do B given C, I guess. I don't know. I drew the Venn diagram so you could, so we could trace what's going on, where the events were, that kind of thing. Okay, guys? All right. What's A in the Venn diagram? This obviously is the sample space, the whole thing. Where's A in the Venn diagram?
The top row.
Top row, is it not? Does everybody see that this is A? Or maybe I should phrase it, does anyone not see that that is A? Where's B? Come on, guys, I know it's a Tuesday. It's a bad day for me, too.
Like the.
Okay.
Okay, yeah.
Who was that? Was that Esteban? You get enough to eat Saturday? Yeah. Okay, cool. That's what I wanted to hear. Thank you for coming, by the way. Okay. So, yep, we have A and B. Okay. Do you see why I wanted to change B if B was 1, 2, and 5, how do you circle that or outline that in the Venn diagram, right? It would be discontinuous. You'd have 1 and 2 here and 5 here. And how do you draw that? That's why I was changing things on the fly. Where's event C, guys? What do I outline for event C?
Square.
Where?
1,
You're right.
2, 3, 4.
Is that Kenny?
Yes.
Good job, Kenny.
Yeah.
That's C. Okay. So, does everybody see that? Well, several questions before we move on. In the sample space, which is the outer rectangle, do you see, everyone, that there is no area in the sample space that that isn't outlined or doesn't belong to the numbers 1, 2, 3, 4, 5, and 6? Okay, if we define areas 1, 2, 3, 4, 5, and 6, that's the entire sample space. Do you see that?
Yes.
Everybody, we good? Does everybody see that? Second, does everybody see that the events are all different, obviously? 6 doesn't belong to anything, does it? Doesn't look like it. So 6 doesn't belong to A, B, or C, right? We definitely have intersections, right? For example, the event that we roll a 5, that outcome belongs to 2 different groups, right? Right?
Mm-hmm.
It belongs to event A. It also belongs to event B. It does not belong to event C. If we roll a 2, on the other hand, that only lands us in event C, doesn't it? Right?
Mm-hmm.
What about a 3? Yeah. Yep. If we roll a 3, we land in all 3 events. Okay. Let's find these probabilities now, guys. Okay. What's the probability of B?
1/2.
1/2, right? It's equal to 3 over 6, which is 1/2. Does everybody see that? Talk to me.
Yep.
How about the probability? I skipped over A. What's the probability of A?
1/2 also.
1/2, right? It's a fair die, so any of the 3 events lands us in probability A, any of these 3. So that's 3 out of 6 is 1/2. What about the probability of event C?
Two-thirds.
Okay. How about 4 out of 6 for starters? You'll see why I'm writing down the improper. Is that the term, improper fraction, if it's not reduced? Is that what an improper fraction is? I can't remember.
I think so. And then a mixed fraction is when you have a whole number with a fraction.
Okay.
Yeah, so I think you're right.
Okay. What's the probability of A given B? First off, in English, what does that mean?
So knowing that B occurred, meaning you got a 3, 4, or 5, what are the chances that one of those is also part of A?
Basically, yeah, exactly. Actually, that's the most technically correct. Absolutely. given the fact that we are in B, what's the probability we're also in A? Okay. Now we have this is the exact equation we need, isn't it? The exact expression, right? Probability of A intersect B divided by the probability of B. And that's exactly what we have, probability of A given B. So what's the probability of the intersection? Well, what's the intersection of A and B, guys? Isn't it a 3 or a 5?
Mm-hmm.
Both of those roles are in A and B. So it's a probability of a 3 or a 5. And isn't that 2 out of 6?
Yes.
Yes, no? What's the probability of B? We've already found that. That's 3 out of 6, right? Well, 2 out of 6 divided by 3 out of 6, the 6's cancel and we get 2/3. Yes, no?
Yes.
What's that telling us, guys, in English?
So that there's 2/3. Never mind. I don't know.
That's basically right. That's basically correct. Yep. Yep. So, another way to phrase it is if we know we're in B, what's the probability we're also in A, right? Well, there's 2/3 because 2/3 of A is also in B, as Esteban said. Very good. Good job. Are there any questions on that?
Did we have an equation to find intersect probability besides just looking at the Venn diagram?
You just look at the Venn diagram, and it's A intersect B. We already said is what, 3 and 5? Yes, no. So these are just 2 of the 6 outcomes, and all the outcomes are equally likely. No, these are mutually exclusive events. You can't roll a 3 and you can't roll a 5 at the same time. So they're mutually exclusive. So you just add up the probabilities of the individual events. Right? Which is how we got the probability of A, the probability of B, and the probability of C in the first place. We added up the individual probabilities. Does that make sense, Esteban? Okay. What's the probability of B given A? Well, the cool thing about conditionals is upstairs doesn't change if we flip them, right?
Right.
The upstairs value does not change. It's still 2 out of 6. However, downstairs does because the given condition changed. So what's the probability of A? It's 3 out of 6, right? Which just so happens to also be 2/3. Okay? They happen to be equal in this case. In general, that's not true. Okay? But in English, if we were to say, what just happened? Well, if we know we're in A, what's the probability that we're also in B? Well, it's still 2/3 because 2/3 of A is also in B. Okay? Are there any questions on that? Normally, when you flip the conditions, the probabilities are going to change, and we'll do a couple examples that are where it's going to be. Actually, the next next thing we're going to look at is that case. Any questions so far, guys? Talk to me. We good?
Yeah.
Everybody good? Anybody not good? Hearing nothing, we're going to move on. What's the probability of A given C? Well, we have to find the intersection, right? And the probability of the intersection. What's the intersection of A and C?
1 and 3.
I get 1 and 3, right? Right? Talk to me, guys. So probability of rolling a 1 or a 3 is 2 out of 6. What do we divide by? What's the probability of C?
4 out of 6.
4 out of 6. Which is 2 out of 4, which is 1/2. So if we know we're in C, which is the rectangle outlined in hot pink, what's the probability that we're in A? Oh, it's 1/2. 1/2 of A is also in C. Wait a minute. Do you guys see anything? Anything kind of weird?
1/2 of A is in C.
Mm-hmm.
But there's 3 members of A.
Right. What's the probability of being in A if you don't know anything else? 1/2. What's the probability of being in A if you know that you're in C? 1/2. Does the fact that you know that you're in C affect the probability that you're also in A? I think somebody said it. If you know you're in C, the probability that you're also in A is 1/2. If you don't know anything about where you are at all, the probability that you're in A is still 1/2. Do you see that the fact that we know that C has occurred, that
Oh.
doesn't change the probability of A at all?
So does that mean it's not actually conditional?
It's not conditional at all. If the probability of, here, let me write it over here. Let me write it over here. If the probability of A given B, in general, guys, equals the probability of A, that means that A and B are independent. If the conditional is equals the unconditional probability. The conditional didn't tell us anything more than what we had before. Doesn't give us any more information. In our examples that we talked about last week, we said that, event A it's a Tuesday, event B is, or it's supposed to be rain tomorrow and tomorrow's a Tuesday. We said that they really didn't affect one another, right? If we know it's a Tuesday, that doesn't tell us whether what the probability is that it's going to rain. If we know it's going to rain, that doesn't really tell us that it's a Tuesday, right? Those two events have nothing to do with one another. They are independent. Okay? Does it make sense to everybody? I have one buyer, so that's good. So we know that the conditional probability of A is independent of C, right? We know that. What's this? Do you think this equals the probability of C?
It should.
It should, but we have to prove it. Okay. What's the probability of C given A? Well, it equals probability, of course, guys, C intersect A, which we already have, divided by the probability of the given condition A. So we know that the intersection is 2/3, yes, no? Or 4/6. Let me write it as 2/6. I'm sorry. What am I thinking? 2 out of 6. What's the probability of A? 3 out of 6, right? So this equals 2/3, does it not?
Yes.
Well, 2/3, that's the probability of C. Okay, so they are independent. It does go the other way. There's also an example of where we calculate one conditional probability and then we flip them and we get a different answer. Okay, when we flip the conditions before, probability of A given C is 1/2, probability of C given A is 2/3. Okay, there any questions on that?
Nope.
Talk to me. Go on. Keep on going. What's the probability that it's a heads, given the fact that you flipped it and it was a tails? It's still 1/2, and that's actually the fallacy of many gamblers, right? Right. Well, I lost 3 times in a row, so I'm bound to hit this time. But they're independent, so that's an invalid statement, right? Does that make sense? See, I'm trying to convince you guys that it makes no sense to gamble.
You didn't account for the luck factor.
Whatever. Luck. Okay. Ready for another example?
Yeah.
Talk to me. Here we go. Can I get rid of this? Going once, twice. Before, like a week ago or maybe 2 weeks ago, we did an example where students were taking a math class and an arts class and a technology class, right? And we had some numbers. Does anyone have those numbers handy in your notes?
I do.
Okay, cool. You can tell me what they are in a moment. We can actually use our work that we did before fairly easily. So suppose we ask a randomly selected student if they are taking math, arts, and/or right science, right, or technology, right?
Yeah, it was technology.
Yeah, we changed it because we can't say science because that's the sample space. So, probability that they say they're taking a math course is
Math is 0.6.
what's technology?
Technology is 0.5.
What's
Arts is
arts?
0.4.
Okay. What's the probability of math and technology?
0.37.
What's the probability of math and arts?
0.22.
Probability of arts and technology, both.
0.15.
And the probability of all three, was that 05?
Yes, it was.
0.05? So, this is the burning question I've had for the past 2 weeks. What's the probability that a student is taking a math course given the fact that they're taking a technology course? It really hasn't been burning in my head too long, but anyway, it is an interesting thing to think about. Well, guys, it's plug and chug, isn't it? This equals the probability of math and technology divided by the probability that they're taking a technology course, because that's the given condition. Okay, well, what's math and technology? What's probability of technology? 0.5, right? So I get 185. Is that right? Did I do that right? I don't. Multiply by 2, multiply by 2. Yeah, I screwed that up. So what is it? How about 7.4? I wouldn't be surprised if that's fairly accurate. I'm not sure. What's the probability? Let's flip them. Probability that they're taking a technology course, and again, we put physics in there, chemistry in there, any of the engineering courses, of course, right? All that kind of stuff, right? So what's the probability of that given the fact that they are taking a math course, right? Well, again, it's easy because, well, somewhat easy. The top is easy because it's the probability of the intersection of the two. Where do you know what that is? Okay. Going to get a slight, I can't do that in my head. We're going to get a slightly lower number than what we got before.
It's,
0.62.
yeah.
So, if we know that they're taking a technology course, the probability they're taking a math course at the same time is 0.74. On the other hand, if we know they're taking a math course, the probability that they're taking a technical course is a little bit lower, 0.62. Okay. So this is how conditional probability works. You should have in your notes the numbers that we need for this. What's the probability that they're taking a math course, given the fact that they're taking only one of the three? Didn't we find this given condition? Oh, but this is going to be nasty. What's the intersection of math and only one of the three? Only math. Did we find that?
I thought we did, but I'm not seeing.
I thought we did
Oh, I
too.
do have it. The probability of only one is 0.17.
And what's the probability that they're taking math and only math?
Is it 0.6? Never mind.
I don't know. This equals the probability of math minus the probability of math and arts. Right, we're just subtracting out the intersections minus the probability of math and technology, but we subtracted out the probability of all three one too many times, so we have to add it back in. Right?
Yes.
I have
So
0.06.
0.06. Well, let's double check that because I sense some confusion. What's the probability of math and arts? 0.22. Probability of art, math and technology is 0.37 plus 0.05. So that's going to be, 0.6. Is that what you guys said?
Yeah.
0.06. Okay, very good, guys. Excellent work. And what do you get? It's going to be a little higher than 3.3, I believe.
0.35.
Very good. So we can apply conditional probability to, quite a few settings. Okay. Quite a few situations, and I have one right here. Are there any questions so far, guys? Talk to me. We good?
I think so.
Okay, here's an interesting one, or at least I think it's interesting. Are there any questions on this one? Talk to me. We good? Can I get rid of this? Going once, going twice. Okay, now, give me an example of a gizmo that you purchase or that people purchase that might have a couple of optional accessories with it that they might purchase as well. If you buy a cell phone, you can buy a case, right?
Yes.
What's another option you can purchase with a cell phone? Are there any?
Headphones?
Headphones? Okay.
A charger?
How about okay, a charger. Okay, all right. Who works in the cell phone store? No volunteers, huh? Who have I not picked on this? What's that?
I said me.
No, we already picked on you.
Not actually, though.
Brandon, do you work in a cell phone store? Is Brandon White still online? Okay. Do you work in a cell phone store kind of thing?
Nope, but I can for this.
I was going to say you do today. A cell phone salesman. Okay. So, Brandon, do you work in one of those fancy, like the AT&T store or the Verizon store or something like that? Or are you selling cell phones at a kiosk in the mall, maybe?
I'm feeling the kiosk, honestly. I feel like that's more. I'd be in my zone there.
Okay. Well, you could sell them out of the back of your van.
I love that. There we go.
Okay. So we won't ask where they came from, okay, guys? Yeah.
Door-to-door phone salesman.
From the back of his van. Okay. Now, customers, so cell phone customers, right? Can also purchase, right? What do we say? A case, right?
Yeah.
A case, which is event A. All right, let's make it event C, huh? Or a what? Charger?
Yeah, we said
It seems
charger.
like everybody's got a charger. Although,
Maybe it's a car charger.
okay. Which is the event? We can't call it C. What do you want to call it?
H.
Okay. We were while we were traveling on vacation this summer, which is something we rarely do anyway. Coffee break, sorry. So we're in this rest stop, right? And it's I forget which leg of the journey we were on. It seems like we were. I can't remember where we were headed. We might have been headed to Roanoke. We stayed a night in Roanoke, Virginia. We might have been headed there, maybe. Anyway, so we're at a rest stop, right? Because my son had his kids with him, his two boys, my son's family, and my daughter and her husband had little Gio with them. So there were three 3 kids under the age of 4. Well, 4 or younger. Anyway, so we stopped at a rest stop and everybody stretched their legs a little bit. Kids got out, walked around a little bit, and it's like literally 1:30 or 2 in the morning. And this random gal was also at this rest. Everything's closed, of course, because it's so late. Just the restrooms and like the area where they have the map of the area. And anyway, she goes, "Does anyone have a charger I can buy?" I'm like, "Well, I actually looked for one, but I couldn't find one." So she would have paid like $50 for a car charger, I think. Anyway, so not everybody has one, obviously. Okay, I get or buy an extra one from Brandon, right? Yeah, see, he's got them, right? Okay.
And he keeps them in his car.
Well, yeah, in the back of his van. Yeah. He'll set you up, definitely. Just don't ask where he got it from. Okay, you might not want to know.
And he won't ask what you're using it for.
That's true too. I mean, we're talking no questions asked policy, right, Brandon? Yes, no.
Oh yeah.
Yep. I won't ask. I want to. I don't. You don't ask the customers questions. They don't ask you questions. Okay. All right. Gotcha. So, what's the probability of the event C?
We're just making it up.
Yeah. Oh, definitely.
I'm
thinking like
0.82.
Yeah, I was going to say fairly high, right? Can we make it 7.5 to make the math easier?
Oh yeah, I thought you were okay.
What's the probability of a car charger then? Given the story I just told you, it's probably higher than we think. %? Does that work for you guys?
I can live with that.
So 2 out of 5. That means 2 out of 5 customers. And guys, it doesn't mean. Let's say it's the AT&T store. Think in terms of that as well. These numbers are probably not incredibly far off, I would think. What's the probability of both? Because we're going to need one, right? If we're going to figure out the probability C given H, blah, 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 right? We need the probability of both. And there's, before we answer this, there's kind of an interesting human thing that we need to think about. Have you ever noticed that, and maybe you're like this too, I don't know, but the vast majority of people are, vast meaning like probably 80, 90 plus percent. People think in relative terms. Okay. If you're purchasing a burrito at Chipotle, right? Burritos are $7-8, right? Ish.
Yeah.
Yes, no. Right? And that's if you don't get the extras that cost money, right? In other words, I think guacamole costs extra, doesn't it?
Yeah.
Right? So, what's that? How much extra does it cost? Is it like $1 or? Okay. For talking purposes, let's call it $1. Have you noticed that people will think, I'm buying a burrito, it costs $7. I'm not going to pay that extra $1 for the guacamole. It's too much. Right? Oh, probably. Now let's turn to you're buying a car. Okay. Let's say you're buying a car at a dealership. Not a new one, not necessarily a new one, but let's say it costs $5,000. Or let's say let's say the dealer wants $6,000 for it. Okay. So you say, well, that's a little out of my budget. I can go as high as 5. Right. So are you going to say no if the dealer says, well, I got to get at least, let's say, 5,100 for it? Most people would agree to that, right? Even though it's costing them $100 more than what they were planning to spend, right? Yes, no? But compared to the dollar guacamole, exactly. It's everything's relative, okay? So that extra, 14%, 15% for guacamole, I'm not going to pay that, even though in specific terms, actual terms, it's $1. Okay. But after you get your burrito, you're going to go out and buy a new car and you're not going to quibble over $100. Most people are like that. And it's been proven actually psychologically. People think in relative terms. So, if you're at the cell phone store, even if you have a warrant with our plan, which is probably horrible, if we have a warranty claim, it's like you have to pay $100 or something like that. I think. If you buy a new cell phone and it's out of the freebie warranty, which is probably like 6 months. If you've had a cell phone a year and it breaks, you can turn it in for warranty, and I think you have to pay $100. I think. Right. If you have to buy a brand new cell phone outright, how much are they? How much is an iPhone?
Top of the line over 1,000, like the new ones.
Right. So, even if you're getting an upgrade or something like that, it's going to be several $100s if you're turning in an old one. Again, depending on your plan. So we say, well, if a cell phone case costs $30, what I'm trying to get at is an awful lot of people are going to pay that $30. Even though they may not need it, right? I definitely need it because I'm always dropping stuff.
Yeah, if you're
whereas,
like touch screens, you need one.
Yeah. And with the car charger, well, I've already got a car charger, right? Why would I need another one? Why would I need to pay $20 for another charger? $20 is grossly overpriced for a charger, is it not? I think
Maybe.
they are. I think they're like $10 if you buy them from a store. Anyway, people in general, they think in relative terms. So the probability that people are gonna buy both probably isn't like 2% or something like that. It's probably far higher than that. So just give me a number for what you think the probability of both is. Remember, it's got to be less than the smaller of these two numbers, right? Or less than or equal. Say
I'm
1/4.
I was going to say like 30%.
Okay. Can we make it 1 out of 3?
Yeah.
Okay. So, guys, what's the probability of a charger a case, given that they also purchased a charger?
We're at a 10-minute warning, just so you know.
Thank you. We'll play with this problem and then probably wrap it up. So what's the probability of C given H, guys? What's the given condition? I spotted you the number upstairs, or what we need to find upstairs. we have to divide by the probability of H, right? That's the given condition.
Yes.
So what do you get?
5/6. Oh, sorry. 1/3 over 2/5.
I'm sensing something over 15, right? Divided by 10 out of 15. I get 1/2. Yes, no? No, this isn't 10 out of 15. I was thinking 2/3. 2/5, 6, right? I get 5 out of 6. Is that what you said, Brian?
Yes.
5 out of 6. So what's that telling us in English, guys?
If you bought
If we know, go
if
on.
we know that you bought a charger, it's very likely that you bought a case. 5/6.
Very good. How about if we flip them? Yes, no?
Yeah.
So this time, if we know they bought a case, what's the probability that they also bought a charger? Well, upstairs stays the same, guys. What's downstairs this time? 3/4?
Yes.
This time I'm sensing something over 12. 4/12 divided by 9/12. I get 4 out of 9.
Yes.
Yes, no? What's that telling us, guys? If we know they bought a case, there you go. So less than 50-50, right?
Yeah.
Where this is a near certain, well, I don't want to say near certainty, but it's certainly much more likely that they're going to buy a case if they bought a charger than the other way around. Are these two events independent? In other words, if they bought a case, does that affect the probability that they bought a charger as well, or vice versa? Does one affect the other? They are dependent upon one another, right? Do you see that,
Yeah.
guys? What do you think?
I think that makes sense because, like, even in real life, if like it's not very likely that you're just gonna buy the charger and not a case. But if like you get the case, you're probably just gonna pick up the charger as well.
There's a reasonably good chance you will, but
Yeah.
most people value the case. If they're buying extras, they're going to value the case, right,
Oh yeah.
rather than the charger. Now, there's a name for this. The probability of H and the probability of C are what are called the a priori probabilities. If you're wondering if it's Latin, it is. What do you think a priori means? Take it apart.
Priority.
Or just prior, right? A priori means beforehand or prior knowledge. That's what a priori means. So the individual probabilities that we had to start with, they were the probabilities that we knew before we knew anything else. Okay? Customer walks into Brandon's store. These are the probabilities. We don't know anything else. Okay? But if we do know that they bought a charger, This is now the probability
Okay.
that they also bought a case. This tells us more information because we had more information to work with. And the opposite is true as well. Do you see that, guys? We have 5 minutes. We have just enough time, I think, to. Oh, here's that blasted. Yeah. Did I get it right? Kind of. Here's that example I was looking for. Anyway, doesn't mean anything to you guys now, which is fine. Okay. Here we go. Are there any we can set this problem up, then we'll hit the math on Thursday. Does anyone have any questions on this one? Talk to me. We good? Can I erase it? Going once, twice?
Go for it.
Okay. In our next example, we have a repair shop. So who's going to be who's going to be the repair technician? The guy making the repairs. Who have I not picked on? Chris, have I picked on you? Or is Chris online?
Hey, I'm here.
Have I picked on you yet? I don't remember.
Yeah, the first time
I-
with the pizza shop. That's all right.
Charles, have I picked on you?
He said you can pick him.
Okay,
He
here we
just
go.
has to type.
Charles, what do people purchase that they might take in for repair? How about cell phones? Do they replace touch screens and stuff like that in cell phones, don't they? Do they still do that? They used to. Okay. Is there anything else people might buy that would
Ours.
people take a microwave in for repair? I don't know. Yeah, I want to avoid the car. Well, okay, fine. At a car repair shop. See, the problem with cars is people are pretty passionate about them. You know, wait, that's my car. What are you saying? Anyway, let's make this a Chevy repair shop, okay? Chevrolet. Sound good?
Okay.
So maybe it's at the dealer. I don't know. Or maybe it's like right next to the dealer. So Charles works only on Chevys at his repair shop. Okay. Now, the dealer sells three kinds of Chevys. Okay. What's the lowest end Chevy there is?
Probably like
They used to sell something like really, it was
I think
actually
it's like a Spark. They have like
Okay.
a really small hatchback. I don't know what it's called.
I googled it and it's a Chevy Spark.
Oh, I got it.
What's like a mid-range Chevy?
Like an Impala or a Malibu.
Malibu. What's a high-range Chevy?
or a truck, Silverado.
If we could keep it to cars, that'd be good, just to make it a little bit more believable.
Camaro?
Corvette.
Motion detected at the garage.
Where was it?
Let's say, let's lump them together. Sound good?
Okay.
Now, this is another reason I wanted to avoid the automotive thing. The probability of selling a Spark is 0.50. Okay? Because it's the cheapest. The probability that a salesman is going to sell a Malibu, what do you think? Maybe 0.4?
Okay.
Right? There aren't, guys, you would agree that there's not a lot of Camaros and Corvettes sold, yes, no?
Yes.
Let's say 0.10. Okay? All right? So, if you did the Venn diagram, guys, we would have something like this. And this, of course, is our entire sample space. Do you see that between the three events, that takes up all of the sample space?
Mhm.
Okay? All right, we'll pick it up here. We're out of time. I just looked at the clock. We're actually a couple minutes over. We'll pick it up here on Thursday, okay, guys? Any questions?
No.
No.
Okay.